So when we were talking about polynomials in general, we noticed that there were some patterns that came up when we were graphing them, right? X cubed graphs and any other kind of X graph with a odd exponent tend to look the same. And X squared graphs and any other graph with a square or an even exponent, those tend to look the same. Okay. So what we're going to do today is we're going to use that knowledge to figure out what the end behavior of our graph is going to look like. Okay. So what end behavior, what that means is that we're talking about what happens on the ends of the graphs. Okay. So there's two ends of the graphs, one going in the positive x-axis direction, one going in the negative x-axis direction. And we just want to know like does it go up at the end or does it go down at the end, right? And over here, is it going up or is it going down? Okay, so like what's going on at the ends? Okay, so when we talk about end behavior is what happens to the graph as x approaches infinity or negative infinity. Okay, and the symbol for those, infinity, it's kind of like a sideways 8, and then negative infinity is like a negative sideways 8. Okay, it's supposed to look a little bit fancier than that. It's a little bit more swoopy. I usually just draw two like circles next to each other, which is close enough, but it's supposed to be kind of more, I don't know, it's kind of elegant and pretty. Yeah. Anyway, all right, so first thing that I'm going to remind you about is on your coordinate plane, this is going to feel stupid, right? But you got your x-axis and you got your y-axis. This is the positive end, that's the negative end. This is the positive end, that's the negative end, right? So when we are talking about our end behavior, when we talk about the infinities, when you're looking at this side of the x-axis, this is going to be positive infinity. This side of the x-axis will be negative infinity. Okay, on the y-axis, this side will be positive infinity and this side is negative infinity, right? That's what we're talking about here. So you're just talking about going forever in one direction or the other. Okay? All right, so now that we've established that, there's this lovely little table down here that we're going to fill in, and we're going to talk about what happens as your leading coefficient is positive or negative, and as your degree of your polynomial is even or odd. Okay, so you're not going to want to memorize this table. You're going to want to make sense of this, and once you can make sense of it, these are going to be pretty easy to do. Okay, so the first thing we're going to talk about is any function with a positive leading coefficient and an even degree. Okay, so as an example, it could be something like f of x equals 3x to the 6th plus 2x to the 5th. Okay, so this is an example because the leading coefficient, the number in front, has to be positive, right? And the degree, the highest exponent, is even. Okay, so that's what we're talking about when we say this. Okay, anytime that happens, right, here's what your graph is going to look like. Okay, anytime it's even and positive. Okay, even means it's going to look parabola-y, right? So it's U-shapey, and since it's positive at the front, there's no flip. So it's definitely going to have ends that are going to go something like this, like a U would. Okay, but I don't necessarily know that it's a U, right? It could be anything in here, right? I don't know what that bird looks like. Definitely doesn't look like that because you can't curve back on yourself. Let's fix that. Something like that. That's terrible, right? So it might look something like that, right? I don't know what is going on in this bit, right? This bit right here is a complete mystery. I can't predict that based on this equation, but I can predict what the ends are going to look like. Just like a regular parabola, they're going to go in this direction and they're going up because it's positive at the front. All right, great. So now that we've determined that, now we have to actually write what our end behavior is. So you're going to have a little mini math sentence for each end of your graph. There'll be one for each. Okay, so here's what we're going to say. This is my x-axis. This is the positive end. That's the negative end. Positive end, negative end, right? So what's going on this end is that as x approaches positive infinity, because we're going to the positive side, right? F of x is approaching, it's going towards the positive side. So it's approaching positive infinity. Okay, so that's what's happening on this end. As your x values are going positive, so are your y values. All right, and then on this side, we're going to say that as your x is approaching, well, now we're approaching the negative side. So we're looking at negative infinity for the x-axis. Your y values are also they're going towards the positive side. So your f of x values, your y values are approaching positive infinity. Okay, so this is going to be kind of what the setup always looks like. Okay, it's going to be something like this, and you basically are deciding, is it positive or negative? Okay. All right, so that's what the first one will be. So let's look at this one. So even degree with a negative leading coefficient. All right, so an example of what this equation might look like, it might be something like f of x equals negative 8x to the 10th, right, minus 3x squared plus 2. I don't know. I just made that up. Okay, where again, this guy, my leading coefficient, that's negative, right? And my degree is even. Okay, so what do I know about this? Well, it's an even degree, so it's going to be parabola E, right? But since it's negative, it's flipped upside down. So it's going to be something like an N shape. My two ends are going to go like this. And again, I don't really know what's happening in the middle there. Anything could be happening in the middle here. This bit right here, I have no idea what's going on. But I do know that the two ends are going to look like that. Okay? All right, so then from there, we can go ahead and write our end behavior. So remember, positive, negative, positive, negative. So on this side, I'm going to say that as x is approaching positive infinity, because I'm going towards the positive side, f of x is approaching, right? My y values are going down, so those are approaching negative infinity. All right, and on this side, I'm going to say that as x is approaching, well, I'm going towards the negative side of the x-axis, so negative infinity. F of x is approaching, coming down towards the negative side of the y-axis, so negative infinity. And there we go. All right, great. Okay, next up, positive leading coefficient, but an odd degree. So as an example of this one, I'm going to use different notation. I'm going to use y equals, right? And it doesn't really matter, f of x or y, function notation, right? Not function notation. So this one we have a positive leading coefficient like 8 and an odd degree, so we'll call it x to the 11th. Okay, so same deal with this guy. When I think about what my graph is going to look like, it's an odd degree, so I'm expecting this to look like the squiggle, right? It's going to look like an x cubed. And since it's a positive leading coefficient, I'm not flipping anything, right? So it's going to look something like this. Okay, again, I don't know what's happening in the middle. Anything could be happening here. I don't know, right? I got 11 options for zeros. This thing can go up and down a whole bunch of times, maybe. I don't know. Okay, what I do know, though, is I know what the end behavior is doing. Here's positive, negative, positive, negative. So on this side, as my x is approaching positive infinity, okay, and here's the bit that's going to be a tiny bit different, right? We were saying f of x here, because this is an f of x function. Now it's a y function. So now I'm going to say that y is approaching positive infinity. Okay, and on this side, I would say that as x is approaching, I'm going towards negative infinity for my x-axis. Y is approaching negative infinity. I'm going towards a negative for both of them. Okay, and determining if it's f of x or y, you literally just look at the equation that they give you, and if it says f of x, you use f of x, and if it says y, you use y. Okay, so that's nothing complicated or fancy. You just match it to whatever you have. All right, and then this last one here. So say we have something with a negative leading coefficient, so negative x to the 7th, right, plus 2x. All right, so again, I don't know what this thing looks like. It could do something like this, right? That's a possibility. I don't know what's happening in the middle there. You can't tell just by looking at the equation. So I don't know what's going on there, but I do know that the ends are going to look like this. It's an odd degree, so it's going to look like a cubic. Oh no, but it's flipped. I was totally wrong. My bad. Sorry. I was so caught up in making the squiggles, right? It could look something like that. Okay, it's an odd degree, so it looks like a cubed, but it's negative, so it's been flipped. Okay, so that's more what this is going to look like. Oops. All right, so when I describe my end behavior, positive, negative, right? So on this side, I'm going to say that as x is approaching positive infinity, y is approaching negative infinity because I'm going down. And for that side, I'm going to say that as x is approaching, I'm going towards the negative x-axis, so negative infinity, y is approaching positive infinity. All right, and then there we go. That is my end behavior. Okay, so end behavior seems really complicated, but as long as you can kind of look at this and like think your way through it, like match it to, is it going to look like an x cubed or is it going to look like an x squared? And then is it flipped or is it not flipped? Then you can get like a general sketch idea. And once you have that, you should be able to do the end behavior without too much trouble. It's weird, it's different because you haven't done this notation before, but once you get used to it, it's really fairly easy.